So in looking at this problem right here, okay, even disregarding the images for right now, you should be able to answer all of these questions up here based on just what you see from this function and the multiplicity of its factors here. Okay, so when you are looking at this, the first thing that it asks are the y-intercepts. Well, to find the y-intercept, there is only one y-intercept, and all polynomial functions will have exactly one y-intercept. And the way that you can find that is you just plug in a 0 for the x. So really you're evaluating f of 0. And so in solving that, you get 0 minus 1 squared times 0 plus 2 cubed. And so that's going to get you 1 times 8. And so you know that your y-intercept is going to be 8. Okay, so even just looking at that, you can eliminate this graph from contention and this graph from contention because they don't have the same, or they don't have the right y-intercept. Okay. Next, you're going to find the zeros. Well, the zeros are where your factors are equal to 0. So you have two different factors. If you set each of those factors equal to 0, you get your 0. So the value of x that gives you a 0 here is 1. So 1, 0 is one of your x-intercepts. And the value of x that gives you a 0 here is negative 2. So negative 2, 0 would be your other intercept. So once again, you see that in both of these graphs, 1 and 0 are your intercepts. Okay, next you're going to look at the multiplicity. And the multiplicity tells you sort of what the behavior of the graph is. If it's a 1, it goes straight through. If it's a 3, it's going to curve up and through. If it's a 2, it's going to bounce off. So when you look here at the 0 at this 0 here at x equals 1, you have a power of 2. So that means the multiplicity is 2 for that factor, or that 0. And at the factor x plus 2, the multiplicity is 3. So what you're expecting to happen here is it's going to bounce either up or down. And here it's going to pass through in a curve. So those are what you're looking for at those particular zeros. Okay, now, in order to determine where it's coming from, is it coming from the left and up, or is it coming from the left and down? You look at your leading coefficient and your powers. So this behavior right here has to do with the degree of your polynomial. So here, when you go back to this factored form, you have 3 factors of x here and 2 factors of x here. That gives you a total of 5. So your degree is 5, and your leading coefficient, and all you really need here is it a positive number or a negative number? There's no multiplier out front, or it's a positive 1. So your leading coefficient is a positive. So what that means is your left-right behavior is going to be down to the left. You don't know what's going to happen here, but up to the right. Right? And so you can identify what's going to happen. So you're expecting a bounce at 2. So if you were to just kind of sketch what you expect your graph to look like, you have a 0 at 1. Oops. You have a 0 at negative 2, and you have a 0 at 1. So at this 0 of negative 2, you expect that it's going to start to the left going down. So it comes up, and at this point, it's going to curve through here. So again, you're looking at sort of the curve on this. I'll redraw it here. So it's going to curve through at the negative 2. And then you know it's going to go all the way up. The next 0 is here, so it's going to go all the way up to 8. You don't know, it's not going to necessarily peak at 8, but it's going to come back down at this point, 0, 8, our y-intercept. And then at the 0 of 1, when x is 1, it's going to bounce. So we expect it to bounce here. And so this is what your graph should look like, some form of this. And so when you compare what you see between these two remaining ones, the one that seems to model this curves through here, passes through 8, and then bounces off of 1. So that means that this is going to be your graph. Okay, the final thing that it asks you to do here are actually within these, it asks you, as x approaches negative infinity, so that indicates the behavior of the graph here. As it approaches negative infinity, we can see that our y's go down. So our y's are going to also approach negative infinity. And as x approaches positive infinity here, you see that our y's get bigger and bigger, so the y's are going to approach infinity here. Okay, the maximum number of turning points, again, has to do with the degree. The degree gives you the maximum number of zeros, so there's at most 5 zeros. Okay, but the number of turning points is 1 less than that, so there's a maximum number of 4 turning points. You can see here that there's only 2. Here it turns here and it turns here. Okay, but there is a maximum number of 4 based on what we see, and then again we identified the actual graph of that.